In 1979, a handful of exotic pet pythons slipped into the Everglades, just a few snakes released when nobody was watching. But this tiny human mistake met a wetland with no defenses. Within decades, scientists discovered something unthinkable. Mammal populations almost completely erased, bird colonies collapsing, and a python empire spreading unchecked. Predators with no predators. How did it happen so fast? And what's left to lose? The story of the python invasion doesn't begin with a single act or a lone villain. It's a chain reaction set off by thousands of small decisions, each one tipping the balance a little further. By the late 1970s, Burmese pythons had become a fixture in Florida's exotic pet trade. They were sold as hatchlings, tiny, docile, and easy to handle. But within a few years, those same snakes could grow to lengths that terrified even seasoned keepers. When the reality set in, many owners simply let their pets go. Some were released quietly along canal banks, others slipped away during moves or storms, their disappearance barely noticed. October 24, 1979 stands out as the first official record, a python captured near the Tamiami Trail in Everglades National Park. No one filed a report about who lost it or why, but biologists now believe this was only the tip of the iceberg. Throughout the 1980s, as the pet trade boomed, more snakes found freedom in the wild. Breeders and dealers offloaded excess stock when sales slowed, and private owners faced with 20-foot predators often chose the path of least resistance, release. Then came Hurricane Andrew in August 1992. The storm slammed into South Dade County as a Category 5, flattening neighborhoods and shattering animal facilities. State inspectors reported that thousands of exotic animals, including hundreds of pythons, escaped when cages and breeding houses were torn apart. Facility records vanished with the buildings, but witnesses described seeing large snakes loose in the aftermath. No one ever managed to count exactly how many pythons entered the wild that week, but the timing matched a sharp rise in python sightings across the region. By the mid-1990s, reports of wild pythons were no longer rare. What started as isolated incidents, pet releases here, a storm-damaged facility there, had quietly seeded a founding population. The invasion wasn't a single event. It was the sum of countless choices, each one pushing the Everglades closer to a tipping point. Burmese pythons are not just big snakes. They are engineered for conquest. In the wilds of Southeast Asia, these snakes grow up to 20 feet long and can weigh more than 200 pounds. Inside their jaws, rows of backward-facing teeth grab hold of prey. Along their upper lips, heat-sensing pits let them track animals by body warmth, even in total darkness. This adaptation turns every movement in the Everglades into a potential target, whether it is a marsh rabbit in tall grass or a wading bird nesting in the trees. Unlike native predators, pythons do not need to eat often. A single meal, sometimes a deer or a full-grown alligator, can sustain them for months. Their metabolism slows, and they vanish into the undergrowth, motionless and nearly invisible. As cold-blooded reptiles, they match the temperature of their surroundings and blend into the thermal background. Even the most advanced detection tools, thermal cameras and night vision, struggle to find them. Hunters can walk within inches of a python without ever knowing it is there. Reproduction is the python's greatest weapon. Females reach maturity in just 2 to 3 years and lay massive clutches, anywhere from 11 to more than 80 eggs at a time. The warm, wet climate of South Florida means virtually every egg has a chance to hatch. And hatchlings emerge already large enough to outcompete most native snakes. With no natural predators and endless food, the population does not just grow, it explodes. Every year, thousands more pythons spread across the marshes, each one a perfect hunter, each one nearly undetectable until it is too late. The Everglades offered everything these snakes needed: abundant prey, thick cover, and no competition. In this environment, the python's biology is not just a good fit. It is an overwhelming advantage. Native species, unprepared for an ambush predator of this scale and stealth, simply disappear. The invasion was not accidental. It was inevitable, written into the DNA of a predator built for domination. In 2003, teams from Everglades National Park and the U.S. Geological Survey set out to measure what was left of the native mammals of the Everglades. Their approach was simple: drive the same roads and trails that had, for decades, teemed with life. Raccoons, opossums, bobcats, and marsh rabbits had once been so common that researchers counted dozens in a single night. But as the kilometers ticked by, over 56,000 in total, the data told a story that no one expected. Raccoon sightings had dropped by 99.3%. Opossums were down 98.9%. Bobcats, once a shadowy presence in the sawgrass, had fallen by nearly 90%. Marsh rabbits, a keystone prey species for countless predators, had vanished entirely from core areas. Peer-reviewed studies confirmed the devastation. In zones where pythons had established breeding populations, road surveys and camera traps recorded empty landscapes. The absence was so total that at first field teams suspected malfunctioning equipment, but the silence was real. Where mammals survived at all, they clustered at the edges just beyond the advancing python front. Radio telemetry studies brought the numbers into sharper focus. In 2015, researchers fitted marsh rabbits with collars and tracked their fate. Within months, 80% were killed by pythons. The pattern repeated across species and sites. Wherever the snakes appeared, mammals disappeared. The Everglades, once a mosaic of animal tracks and nighttime activity, had become a void. The numbers were not just low. They were almost absolute. What had taken centuries to build had been erased in less than a generation, leaving behind only the echo of what once was. The python invasion did not spread like a sudden explosion. It advanced as a slow, relentless wave, reshaping the Everglades one section at a time. Biologists began mapping the front line, marking the boundary between landscapes already emptied of mammals and those still holding out. The difference was stark. In the core, where pythons had been established the longest, trail cameras and road surveys revealed almost nothing but snakes. No raccoons, no rabbits, no opossums. Just the silent passage of pythons through abandoned swamps. At the edges, the story was different. Here, marsh rabbits still darted through the sawgrass, and raccoons prowled the banks at night. But the boundary was moving. Each year, the line of disappearance crept north and west, swallowing new ground. Field teams tracked this movement with occurrence maps, plotting every python sighting and every vanishing mammal. The data formed a time-lapse portrait of collapse, dense clusters of wildlife in the periphery fading to emptiness toward the center. The invasion front was not a straight line. It curved and bulged, shaped by rivers, roads, and the stubborn resistance of isolated animal pockets. But it never stopped. Researchers describe the process as a biological wildfire, burning not with flames, but with absence. The spaces left behind were so devoid of life that even the usual background noise, frogs, insects, the flutter of birds, seemed muted. In these zones, the ecosystem's balance unraveled. The python front pressed outward, always searching for new prey, always leaving silence in its wake. The invasion was no longer just a historical event. It was a living, moving force, erasing the Everglades in real time and threatening every area not yet reached. Wading bird colonies in the Everglades, once the largest in North America, began to unravel as the python invasion deepened. For decades, aerial surveys counted tens of thousands of nesting pairs: wood storks, great egrets, tricolored herons, gathered in cypress domes and mangrove islands each spring. By the 2010s, the numbers crashed. In the southern core, wood stork nests dropped from over 10,000 pairs in the 1980s to fewer than 3,000. Great egret colonies shrank by more than half. Entire rookeries that had withstood hurricanes and droughts for centuries emptied out in a handful of seasons. The cause was not subtle. Field monitors documented pythons climbing 20 feet into rookery trees at night, their bodies draped across limbs heavy with eggs and chicks. One 16-foot python, found in a mangrove rookery in 2012, had swallowed 23 eggs and hatchlings in a single night. The adults abandoned their nests, leaving the site silent the next morning. In 2015, a python regurgitated 5 tricolored heron chicks after a capture in Big Cypress. Gut content studies from hundreds of removed pythons confirmed wading birds made up a growing share of their diet. Monitors who had spent years tracking colonies described the change as a kind of mourning. The calls that once echoed through the trees fell quiet. Abandoned nests collapsed into the water, unguarded and empty. In some sites, not a single chick survived to fledge. Even efforts to restore water flows and habitat could not protect the birds from a predator that hunted by stealth and patience, returning night after night until nothing remained. The loss rippled outward. Without birds to disperse seeds and cycle nutrients, plant communities shifted. The Everglades, shaped for millennia by the rise and fall of bird colonies, now faced an emptiness that restoration alone could not fill. The silence told its own story, a system unraveling from the top down, with no natural check to halt the decline. Florida's response to the python crisis began with optimism and urgency. State agencies launched removal programs, fielded expert hunters, and offered cash bounties for every snake brought in. Contractors worked through heat, rain, and clouds of mosquitoes, combing the sawgrass for hours. Some nights, a team might capture a dozen hatchlings or wrestle a 15-foot adult from the reeds. In 2024, the Florida Python Challenge drew 850 hunters who removed just 200 snakes in 10 days. Over 24 years, the combined effort of government programs, contractors, and citizen hunters has removed about 17,000 pythons from the wild. The numbers sound impressive until you compare them to what is left. Biologists estimate the Everglades population is at least in the hundreds of thousands, possibly more. Removing 17,000 snakes in 2 decades represents only 2 to 3% of the total, while the population grows by 10 to 20% every year. Each female lays up to 80 eggs, and even a single missed nest can undo months of work. The math is relentless. For every python removed, dozens more are born and slip undetected into the swamp. Finding the snakes is the hardest part. Burmese pythons spend most of their lives motionless, buried in thick vegetation or submerged in water. They match the temperature of their surroundings, making them invisible to thermal cameras. Trained dogs can sniff them out, but the heat and waterlogged terrain wear them down quickly. Nighttime spotlighting, traps, and even drone surveys catch only a fraction. Most pythons are never seen at all. Scientists turn to technology for help. The Judas snake technique involves implanting a radio transmitter in a captured male, then releasing him back into the wild. During breeding season, the male seeks out females, leading hunters to hidden nests. This method removes dozens of breeding females each year, but it is a drop in the bucket against the millions of eggs produced across the Everglades. Every removal is a victory, but the overall impact is almost negligible. The arithmetic is unforgiving. With double-digit annual growth and only single-digit removal rates, the population gap widens each season. The harder people work, the more the numbers reveal the scale of the problem. The fight is not just uphill. It is mathematically impossible to win with current tools. In 2019, a team of USGS geneticists published a finding that startled even seasoned biologists. DNA sequencing of python tissue samples from across South Florida revealed something new. The Everglades population wasn't made up of just Burmese pythons. Mixed among them were hybrids, offspring of Burmese pythons, and northern African pythons, a species with a reputation for surviving colder, drier climates. The genetic signatures were unmistakable. Out of more than 200 samples, 13 were confirmed hybrids, each one a living experiment in adaptability. In controlled laboratory trials, these hybrids endured cold snaps that killed pure Burmese pythons. Where Burmese pythons froze and died after 2 days at 4 degrees Celsius, hybrids survived, sluggish but alive. Field observations soon matched the lab results. Hybrids turned up farther north than any Burmese python had been found before, sometimes well outside the historic range mapped just a decade earlier. The coldest winters in Florida, once considered a natural barrier, no longer offered the same protection. USGS researchers fed this genetic data into climate suitability models. The projections were sobering. With just a small fraction of the population carrying hybrid genes, the potential range for pythons expanded dramatically. Maps once shaded only the southern tip of Florida now stretched west along the Gulf Coast, reaching into Louisiana and Texas. Under current warming trends, suitable habitat could extend as far as Houston by mid-century. Invasions that once seemed limited to the Everglades now threatened entire regions. The hybrid pythons weren't just a curiosity. They represented a leap in evolutionary potential, combining the size and reproductive power of Burmese pythons with the resilience of their African relatives. For biologists, the implications were clear. The invasion front would not stop at the boundaries of the Everglades. Every cold-tolerant hybrid that survived a Florida winter could become the founder of a new population, far beyond the swamps where the crisis began. There is no way to predict exactly how quickly these hybrids will spread, or how many will survive each cold snap. But the genetic evidence points in one direction. The python invasion, once a local disaster, is poised to become a regional threat. The Everglades, emptied of its native mammals, may only be the first chapter in a far longer story. Right now, mammal populations in the Everglades remain down by over 95%, and python hybrids are pushing north as temperatures rise. This is not just a Florida crisis. It is a warning. When ecosystems lose their balance, recovery is not promised. Sometimes the damage writes a permanent chapter. Let me know your thoughts below.